Hello everyone, this is Dr. G. Karthik Reddy, working as Associate Professor in the Department of ECE, MLR Institute of Technology, Hyderabad. And today's lecture topic is Problems on Continuous Random Variables. Problems on Continuous Random. Okay, today's lecture overview is, we are going to discuss the problems on expectation of continuous random variable, variance of a continuous random variable, cumulative distribution function and probability density function of continuous random variable. Now we'll discuss with the problem. Let x be a random variable with probability density function given by fx of x. Fx of x is equal to c into x square, and here the modulus of x is less than or equal to 1. Means here modulus of means x lies between -1 less than or equal to x less than or equal to 1. Next 0 otherwise. Means the interval which is satisfying between the interval -1 to 1. -1 to 1, the condition of this is cx square, remaining part is 0. Now next, what we have to find out? Find the constant c. Find the constant c. Second question, find the expectation of x and the variance of x. Next, third one, find the probability of capital X greater than or equal to 1 by 2. Okay, now first question, how to solve the first question? They are asking to find the constant c. Find the constant c, how to calculate it? First, you know the one of the property from the density function, that the area under the curve of any density function is always equal to 1. That is called valid density function. Okay, valid density function tells that integral -∞ to infinity fx of x dx is always equal to 1. Which indicates that the area under the curve is always equal to 1. Now here the interval, here the x interval is from -∞ to infinity. But what is our interval we required? We required the interval from -1 to 1. The condition is satisfying from -1 to 1. Here fx of x is cx square dx equal to 1. Now you simplify this integration, you will get the resultant part. That part I already simplified. You can check it here. To find the c, constant c, we can use the integral -∞ to infinity fx of x dx or fx of u. Okay, you can take any variable. Here it is equal to 1. You simplify it, you will get the answer 2 by 3 c. Then what do they want to calculate? C. C is equal to 3 by 2. We got the first one. Now second one. What is the second one? We want to find out the expectation of x. Expectation of x. What is the formula of expectation of x? Okay, expectation of x of any particular random variable is equal to, here the integration -∞ to infinity x into fx of x dx. Okay, fx of x dx. Now next, if you want to calculate the variance, first you have to know the calculation of mean square value. What is the mean square value? Expectation of x square is equal to integration -∞ to infinity x square fx of x dx. Now next, what is the variance definition? Variance of x is equal to mean square minus mean of square. Mean square minus mean of square. Okay, these are the definition. The problem which I have solved already. Okay, you can check it here. Expectation of x. Expectation of x, here the x value lies between -1 to 1. X into fx of x dx or u into fx of u du. Okay, here you can check it. Okay, integral -∞ to infinity x into fx of x dx. What is the fx of x? We already calculated. Fx of x is c into, okay, c into what is the variable you are having? C into x square. Okay, c into x square, okay, dx. Okay, here the x, you change it -1 to 1, c into x power 3 dx. Now here c value we already know that, which is equal to 3 by 2 into x power 3 dx. You simplify it further, then you will get the 3 by 2 x power 4 by 4. Okay, substitute the intervals, you will get the answer for expectation of x. Now to calculate the variance, okay, to calculate the variance, first you have to calculate the mean square value. And what is the definition of variance? Mean square minus mean of square. Mean square minus mean of square. Same thing, mean square minus mean of square. We are going to calculate it. Okay, here when they given that, okay, when it is symmetry of port x equal to 0, we can find variance directly by taking only the, what is that, mean square value. Okay, when it is symmetry, what happen? Whatever the RHS part which is equal to the left side part, both will cancel out each other, then the resultant expectation will become 0. Okay, when x equal to 0, this condition is happening only at x equal to 0, the expectation of this condition is always equal to 0. Then here that is a 0 we got already. Then you can substitute here, this is 0. Then what you are going to get? Only mean square value you are going to get. Mean square value, whatever you got, that is the answer of this. Now next, probability of x greater than or equal to 1 by 2. Probability of x greater than or equal to 1 by 2. You are having the condition p of x greater than or equal to x. P of x greater than or equal to x. Here what you are doing, integration is taking from infinity, x greater than x to infinity fx of x dx. But here what is given in the condition in place of x? 1 by 2 to infinity. But the cx square is defined only for the interval minus 1 to 1. Then 1 by 2 to 1, fx of x is x square dx. Okay, we substitute, simplify it, then you are going to get the answer of 7 by 16. 7 by 16. This is the way we have to follow to solve the problem. Now next question. We are going to discuss the next question. Let x be a continuous random variable. Okay, x be a continuous random variable with probability density function. Probability density function is given by this notation, represents density function. Probability density function which is equal to 1 by 2 e power minus mod x for all x belongs to real values. Okay, if what is that? If y equal to, y is another random variable which is equal to x square, find the CDF of y. Find the CDF of y. First, before solving this, you have to know some formulas. Okay, what is mod x? We are having mod x equal to x for x greater than 0 and mod x equal to minus x for x less than or equal to 0. Okay, you have to know this condition. Now next, what do you have to know? The condition, relation between density function and distribution function. Distribution function CDF, capital Fx of x, which is equal to integral minus infinity to x, small fx of x dx. Or you are having one more relation, small fx of x is equal to d by dx of capital Fx of x. Okay, you have to know these two relations to solve this problem. Okay, now next he is asking y equal to x square. Okay, first we will call y equal to x square. Y equal to x square is called a function. You know the formula, expectation of g of x. Okay, or here you are having the function integral minus infinity to infinity g of x fx of x dx. You have to use all these formulas to solve this. Okay, the solution we have discussed it here. Okay, here this is the definition of distribution function. Okay, so you know the definition. If x, here y is a random variable, then fy of y is equal to p of y less than or equal to y. What it represents? Capital Y represents the random variable, small y represents the value assigned to the random variable. And what is that? This definition indicates that the probability of random variable y lies up to the value of small y. Okay, here the y, capital Y is equal to what is given in the data? X square. And what is that? Y equal to x square. Okay, so do the square root, x is equal to root y. But here you are having negative and positive sign. Okay, modulus value minus root y plus y. And this is the interval of the random variable x. Okay, interval of the random variable x. Now you take the 1 by 2 outside the interval. Now you split this interval, then you will get the resultant answer 1 minus e power minus root y. Okay, this is a condition happening only for y greater than or equal to 0. Remaining condition, it is because we are taking only the positive values, because fx of x is always non-negative value. Okay, fx of x is a non-negative value, and this is a condition we have to solve because here they consider in the question that, okay, real values. Okay, they given in the question x is a real value also they given in the question. Now next we will discuss one more problem related to this. Now x is a continuous random variable with probability density function. With probability density function fx of x. okay, the density function, the value of the interval lies between 0 to 1. Okay, 0 to 1, the value is 2x, and the remaining condition it is 0. And what they want, find the probability of which lies between 0.2 to 0.6. Here he given the range of, okay, range is given as 0 to 1. 0 to 1 is required, but we require the probability only between 0.2 to 0.6. Here having the conditions, okay, here having the different formulas. Here having x1 less than x less than or equal to x2. Okay, here having the interval x1, x2 we are taking, and small fx of x dx we are calculating. Okay, this is one condition, and one more is fx of x2 distribution function minus fx of x1. This is another condition you are having. Now next, okay, here you are having the, you can check the relation, same thing I discussed. Because the probability for x in the interval a to b is given by, in the interval a to b, you have to substitute the intervals a to b. There I discuss as x1 and x2. Here you consider as a b. Okay, for the interval lower limit is a, upper limit is b. Small fx of x is the density function dx. And here it is defined. What is the defined interval? You mentioned that, okay, we required only from 0.2 to 0.6. Okay, zero condition part is 0.2 to 0.6, 2x dx. You substitute it, then what you are going to get? 2 into x square by 2. Okay, here 2 gets cancelled. You are having 0.2. Okay, 0.2, 0.6. You simplify it, the substitution part. Then 0.6, 0.2. You substitute it. Then the resultant answer you will get 0.32. Okay, 0.32. Okay, same thing you can calculate for distribution. Okay, you required, what is a problem here? They are asking that. Okay, calculate the probability density function. Okay, x is the random variable, probability density function. Find this one. This one is a distribution function part. Okay, you got the resultant for this probability 0.32. Okay, 0.32. Same thing you can solve for the, okay, in terms of another formula, fx of b minus fx of a. Okay, if you are having the values directly, you can substitute the fx of b and fx of a. In that way also you can solve. This is the second method of approach. Second method of approach of solving this type of distribution and density function of a continuous random variable. In the overview we are going to discuss that. We have discussed the continuous random variable for the expectation, for the variance, for the distribution and density function. Okay, these are the problems related to this concept. Thank you.